This question is about balancing toys, and you must know that for balancing toy to work, it means that when you disturb the balancing toy and you just tilt it slightly, a balancing toy by right should go back to its original position. So that's why it's called a balancing toy. And for all balancing toys that work properly, the CG of the whole object must be below the pivot, and that is the answer to this question. Now I've done up some animation to show you why is this the case. The green color dot is the CG of the balancing toy, which I mentioned is below the pivot, which is in yellow. Okay, so we if it's a structured question, it is worth knowing how can we explain this. The CG of the balancing toy is always below the pivot for it to work properly, because when it's tilted slightly, the weights of this balancing toy will cause what we call a restoring moment that restores the object back to its original horizontal orientation. Now, what do I mean by that? Over here, I have slightly tilted the balancing toy and disturbed it. And my aim is to show why this balancing toy now, when tilted, it will rotate back to its original position. So we take a look at the CG of the whole toy. It still stays in a straight line that is below the pivot point. And the weights of the object always points vertically downwards towards the floor. And from this picture, you can see a very obvious clockwise movement that will make the balancing toy rotate clockwise for it to return back to a horizontal orientation. And this is exactly the restoring moment that I was mentioning about previously, that the weights will create a restoring moment, in this case a clockwise moment, that makes the toy rotate back to the original horizontal orientation.